A field just before the sun is up. 40 sheep packed along one crease of it, tight as a drawn line. In a minute, somebody opens that gate. Before we start walking, I want you holding two questions for me. The first one goes like this. Gathering the same flock two ways. Who pushes harder? Watch that one. He steps off the line, noses about, drifts back, and he never once decides to. Nobody told him where the line was. Nobody is going to. That is the second question, and it is the one I want you carrying the longest. How does a wandering thing know which way home is? The gate goes, and nothing organized happens. This one noses left, because there is grass on the left, then right, because there is grass on the right. Watch the trail behind him. It gets long, it gets tangled, it crosses itself. Now watch the straight line from where he started to where he is standing. That line barely grows. He has walked half the morning and got almost nowhere. And he is content about it. The sun comes up and the crease goes soft. Stop watching the animal and watch the whole flock, the shape it makes, spreading, the edge of it pushing out toward the fence. That shape is a thing. It has an edge you could draw around. And our lit sheep is still in there, crossing it, and his path is not that shape. Two different objects, one field, by mid. Morning the shape has swallowed the pasture, and the line is gone. The shepherd wants his line back, so he sends a dog. This one works them while they are still nosing, and that does not stop. Not for a second, not all morning. So every yard he gains, they hand a little of it back. Watch the rim, he leans in. It puffs out, he leans in again. He is fighting the wandering and the clock, and he is leaning on them hard. All morning, keep an eye on that crook. Different morning, same field, same scattered flock, except these sheep walk. No nosing, no doubling back. Every one of them on a smooth line, going where it is going. Second dog, second crook. And look how little he does. He tips them. And they hold the tip, and that is the end of it. Nothing shoves back at him. Same crease when he is done. And the sun lands where it landed yesterday, on the same mark, the same morning. Both dogs done, both crooks back against the rail. Now, you and I both know how this goes. Same flock at the start, same crease at the finish. Same morning on the clock, two dogs, nothing between them but style, so they did the same work. Whatever the pushing is, both dogs did the same pushing. The wandering is noise on top, and noise averages out. That is what I would have said. Standing at that fence, I think you would have said it too. Except look at the crooks, not the dogs. The crooks, nobody has compared them. Nobody has touched them. They have been leaning on that rail since the second dog sat down, and one of them is worn down into the grain, while the other one looks nearly new. Same flock, same crease, same morning, and a different amount of wood gone off the handle. I would like to know why. Take them off the fence and look. This is dog one's. He worked the flock while it was still nosing. This is dog two's from the orderly morning. Same wood, one baseline. Read the wear off them too. And one, not roughly one, not about one, exactly one against exactly two. The second dog did exactly half the work of the first. A half. So that is the hunt, and it takes the rest of the film. We do not start with quantum mechanics. For the next 4 minutes, there is none in here. We go back to ground you stand on. One sheep, one step. Every step is two things added. There is the part the field does. The ground is crowned, so he leans downhill, and that lean is the same for anything standing there. And the part that is just him nosing, drift plus jitter, 40 years old, none of it ours. Notice the jitter is not the same size everywhere. Now stop watching him. Drop every sheep onto the fence line. Count how many land where. Let the count smooth. That curve is where the flock is. It has a name, the marginal. And be clear what it is not. Our sheep walks off across it. The curve does not go. The curve is what a photograph sees. He is what the day sees.
Okay, but hang on. If two flocks give you the exact same curve, like identical every single morning, then they're the same flock, right? Same picture, same thing. That is what a picture is for. That is the job. I feel like you are about to tell me no.
And the curve has a law of its own. You do not need the sheep anymore. The lean slides the bump. The nosing spreads it out. That is all of it. And one of our papers writes it in its own supplement, exactly like this, so we hold them to it. Run the morning, the bump flattens and keeps flattening into a flat line. Start from a different crease and you land on the same line. The flock forgets. Now both our papers grade themselves on how far one cloud sits from another. Paper A, paper B, same yardstick, and only B ever says what it costs. How would you find the crease if the curve was all you had? Take its log, look at the slope uphill. That arrow is the score, and we borrowed nothing, a tangent on a line already drawn. Watch it at the top, it dies. Out on the flat, there is no uphill. One warning on reading these papers. B uses two conventions for that arrow. Two places plus one main text sentence that fits neither. The proofs still go through. It is the reader who gets tripped, so we write the bracket out in full every time. So reverse it. Let go of the tracker, and it does not rewind. It keeps spreading. 3 things. Flip the lean. Add a term leaning toward where the nosing is wildest. Nobody remembers that one, and it exists only because the jitter changes size. Then the score at the crease. Run it. There is your crease, and the nosing is still on. At the forward strength. Anderson wrote that in 1982. Paper mentions him once, and when it does, it is talking about classical diffusion models, not its own result. B does not mention him anywhere. Both write his equation, neither names it for the quantum case. Now the students' orderly flock. There is an equation for those, just as standard. Take those same 3 symbols, have the bracket, throw the noise away. Same curve at every single instant, different sheep, different paths. Line it up against Anderson identical symbols, 1 factor of a half, and one still has the nosing on. Now look at the rail. So the machine noise your data into fog, learn the score, run it backward, new samples. Except you cannot actually evaluate that score, and the fix is asserted, not proved. The paper says so itself. 3 words for the backward drift minus div score. Run it back once more, it costs nothing now. There is the crease. Everything you watched is classical, old, none of it in dispute. And this is where it stops being easy. What is the score of a quantum walk? Keep the picture, close the fence, bring the 2 ends round until they meet. Lift the field off the ground, let it fill out. Every sheep is a point on that skin. 1 point is 1 qubit in 1 state. The crease is still there. It is a circle now. Before the algebra, meet everyone. Psi, 1 state, 1 point. And a warning on that name, the psi you were taught is an arrow. This one is the matrix that names the point. That is A's convention. And it is why psi can have a trace mu, the whole flock, where the walkers are. Script K. The measurements kick that arrow script D, the averaging blur, upright D, different letter, different color. And I will always say it differently. The kicks squared, 2 arrows crossed, grad log mu, uphill toward home. And these last 2 we are not explaining until they are earned. 2 arrangements a ring, a clump at the 2 poles, genuinely different flocks, and you can see it. Now average each. Every point drops a vector inward, and they pile up. The ring gives you that dot. The clump gives you the same dot. 2 clouds, 1 average, commit to something before I answer. Which is harder, putting the cloud back or the average? The cloud, and strictly so. That is B's own line. The trajectory level objective is the more demanding one. Nothing mystical here. Bring a second qubit, let them talk, read it. It comes out a coin, not a fair coin. The state tips it by root gamma delta t times what you expected. That is all weak means. A bias on a coin, and gamma is lambda squared delta t. The only place either paper says what gamma is. What?
Measurement kills the state. That is the first thing they teach you. You look, it collapses, it is gone. How do you build a generator out of the thing that destroys data?
Watch one trajectory. It wanders and never leaves the surface, pure the whole way. Second, third, fourth, all on the skin. Now average the 4 endpoints. The average sinks inward and goes mixed. The paths are pure. The mixing comes from averaging over the record, solely. And this is the upgrade both papers make on the classical picture paper A. Randomness arises solely from the measurement process and does not rely on additional external noise. Paper B, quantum measurement naturally provides the stochastic processes for diffusion. Nobody sprinkled anything in. The jitter is what the detector wrote down. So this is a forward equation assembled from what you have, the dot steps. Part is a drift bracket. Part is the kicks, 1 per channel, each with its own wiener, 3 channels, 3 arrows, and the drift splits, a coherent half, and the dissipator. Remember that seam. The kick has an ugly term. Watch without it, the dot steps and leaves the sphere. So take the trace of the line. Psi has trace 1. Everything cancels, its trace is 0, always. Nobody chose that subtraction. The sphere forced it. Average over the noise, the dW term dies, and out drops the master equation. That is Lindblad, and know what it is. The average of the trajectories. The first moment, it throws all 4 paths away. A's real Fokker-Planck lives elsewhere. We come back for it. Now, A's one example. No Hamiltonian at all. H is 0, and the coherent half we park dies unfired. 3 Paulus, 3 channels, 3 axes. Write psi as 1 plus r dot sigma. Halved one direction, n hat. Watch spin the sphere, and the fog does not change. You can see that without solving anything. Project every point onto that axis. Call the height z. Now z is linear in psi. No ATD correction. Nothing to fix. Evaluate the drift. Minus 4z. Then the spread 4, 1 minus z squared. The sphere is gone, and the qubit is running on that one line. Where does it end up? Legendre modes diagonalize it. The fast ones first. Read the rungs. D times L, L plus 1. So D is 2 isotropic Brownian motion. And the stationary law is flat in Z. That is Archimedes, parallel planes, every slab equal area, 2,000 years old. That is A's own figure from their paper, used with their permission. 3 stills. Ours runs continuously. Same system. Watch it go. So that is the fog uniform. No crease anywhere in it. Orbit it and check. There is nothing hiding round the back. Somewhere in there is the ring we started with. Your job and A's job and B's job is the same one job. Bring the ring back. Nobody has told you it is hard. Reverse it. Well, you have a master equation. It has a t in it. Put a minus in front of the t and run it. Flip the sign on the Hamiltonian while you are in there. That is what reversing meant everywhere else you have done it. Undergraduate quantum mechanics reverses a unitary by daggering it. So, flip and run.
Okay, wait, I've got it. Look, the state stays pure. Every single step purity 1, it never drops. And a thing that keeps pure states pure is a unitary. That is basically the definition. So it is a rotation, and you just run the rotation backwards, done.
Before we run it, let us be clear who is standing here with you. Paper B makes that inference twice, in print, in a paper that survived 4 revisions and still says it. You are in good company. Now run it. The rotation grabs the fog and spins it, and the density meter does not move. It rearranges the fog. It does not gather it. Two attempts, both still standing. I have not laid a finger on either one of them. The fog is exactly as fogged as when we started. So before I go further, sit with it. What would you actually do here? One thing has to be sorted, or the next step is sleight of hand. What are we running backwards? The average state is one dot, and infinitely many clouds give you that dot, so it cannot be that. We need the law of the cloud itself over pure states. A has one and a joint generator on densities. Lindblad only ever gave us the first moment of it. You own every single piece of what comes next. Take 2 points, x and y. The forward process carries you from x to y with some probability. What is the probability of the reverse Bayes? Take the forward number, reweight by how much fog sits at each end, more fog at y, more ways to get there. That is the derivation. The forward kernel run the other way. Reweighted by the marginals, no calculus. Look at what is left. Everything dims and you stare at two muss, one over the other. The fog now over the fog a moment earlier. Take the log of a ratio, you get a difference. Let the times close, the difference becomes a slope of the log of mu. That is the score, hiding in the reweighting all along. Nothing put it there but the product rule. What comes next is a thicket, a dozen terms, and I will not pretend we walk them. A says, the zeroth order terms cancel, and the terms with derivatives of log mu but not of p tilde cancel as well. 2 sentences, a dozen gone. That is the paper's claim, and here is what it leaves standing. And out it drops, minus the generator, plus div d plus d times the score, carrying the same kicks it had forward, the same noise. Now put the classical line up behind it, term for term, same equation. And nothing quantum went into that step. Bayes and Markov on pure states. The quantum theorem is next on the citation. Anderson wrote this in 1982, names him once, about classical models. B never names him. Read it off, the kicks are unchanged, the dissipator is unchanged, thus d tilde equals d in A's own words. So alpha is finished, the dissipator does not reverse. What the reversal adds is a Hamiltonian that was not there forward. And A is careful. It can be chosen, a family. One prediction before we go on. The equation is up there. Noise term and all. Look and commit. We spend 30 minutes on that. Right, we have a drift and no Hamiltonian yet. Everything after the minus generator, that whole group, call it X. A Lindblad generator needs its coherent part to be a commutator with psi, is x1. Because if it is not, none of this is physics. 4 terms, first the coherent one, then minus twice the dissipator, script d, the averaging blur, and watch the fog thicken as it lands. Then a divergence correction, div of upright d, the kick squared, a different letter, a different color, a different object. Then the score. In ambient matrix coordinates, verbatim, the classical score term from the pasture 4 terms. That upright D is not a matrix you multiply by. It is an outer product kick times kick entry-wise, summed over channels, which is why div D exists, differentiate entry by entry in ambient coordinates. So yes, we compute off the sphere. A diffusion degenerate on a submanifold. Hold that against them if you like.
Hang on. So H tilde just is the score. Like, that is the answer. The denoiser is the score function wearing a hat. That feels way too easy for a whole paper.
Before the next step, a question. In A's reverse, the one we just derived, what happened to the kick coefficients commit? Unchanged, same strength, same dissipator. The reverse stays noisy. Though the noise is a fresh draw, a new Wiener process, new dice. That fact costs B exactly 1/2. Park that. The real question is narrower, and it is the genuinely quantum one now. which Hermitian matrices are commutators with psi. Not all take psi to be 0 ket 0 bra, x to be psi itself. Hermitian, obviously, sandwich. It's psi x psi comes back psi, not 0. So that x is no commutator. A commutator is always empty in two corners, which gives us a test. The whole proof needs one fact: psi squared is psi. That is the input. Sandwich x between psi and psi, substitute the commutator. Apply psi squared equals psi, and it collapses to 0. Same on the complement, same chain, one substitution. That collapses too. If both corners vanish, define h as I times the bracket of x with psi self-adjoint. Because that bracket is anti-Hermitian, 10 lines of algebra, and psi squared equals psi is the only thing you fed it. Now sandwich the divergence term, and it refuses to die. Everything else went to 0. This one comes back as something, twice the sum of alpha m squared minus beta m times psi, which is twice psi script d psi, two different letters, two different objects, and I keep them apart on purpose. D right there, they annihilate.
Okay, no, come on. Did they pick that 2 like, of all the numbers you needed a 2 and a 2 turned up? That is not luck. That is somebody tuning knobs.
Fair, look where the 2 comes from. The generator is I bracket h minus script d. Write the backward drift as script d plus x. Move it across, and minus script d becomes minus 2. Nobody chose it, the sign fell out. And it happens again on the other side. The complement runs the same chain to the same factor. Another root. Both corners vanish. The lemma's hypothesis is met. H tilde exists. We never asked what the score was. Watch why that is allowed. Because D is an outer product of kicks. D times the score is not a general vector. It dissolves into a sum of kicks, each with a number. Slide the number, the arrow lengthens or shortens. The direction never moves. Every kick lies flat in the tangent plane. The state stays on the shell, so the sandwich is 0, always, whatever mu naught was. Back to question 2. How does a wandering thing know which way home is? It does not have to know. It only has to be pushed, and the only directions available are the ones it was already wandering in. The score pushes along the kicks. Which finishes beta A's reverse, keeps pure states pure. Watch the dot. It never leaves the skin. It keeps the same kicks. And it is still stochastic, the path jitters. Purity preserving, non-unitary, random. So the therefore fails. The leap that breaks is purity implies deterministic. Put it together, nothing new is drawn, H tilde from the box, script D, off the rail, kicks off the sphere. Now the forward equation underneath, everything matches but one term. Forward has H, reverse has H tilde. That is the reversal. And A adds a line. The Petz map only reverses the average state. Remember that sentence. A's one worked example, one qubit. No Hamiltonian at all. 3 Paulus as the jump operators. A ring around one axis. That is the whole system. And it is every system A ever runs, which is worth knowing going in. 2 terms stand between EQX and a Hamiltonian, minus twice the dissipator and div D. Everything else is already in shape. And the tool for both of them is 2 lines of Pauli algebra, sum sigma, a sigma, and sum trace sigma, a sigma, completeness, nothing more. Watch the sums light up on the 3 axes. Div D comes out 4 identity minus 8 psi, factor it 4 identity minus 2 psi. Now minus twice the dissipator 4 2 psi minus 1. The same 4, the same bracket, opposite signs. They cancel exactly to 0. And minus and div are gone from the ledger. Only the score is left standing. Before I show A's answer, predict which directions may the reverse Hamiltonian push along. Only the ones the measurement already kicked in. 2f times I bracket n sigma psi. Look at the bracket first, a rotation about n hat, and the dot starts precessing before I say the word. Now the scalar in front, that is the one-dimensional score, and it is what sets the rate, drags psi onto the axis, and the precession stops dead. And on the card, in the paper's words, note that this cancellation is specific to this example and does not occur in general. That is A's sentence, 400 lines from the abstract. So the strip is not struck. It gets amended. H tilde is proportional to the score, in the example only. Two levels, and they are not the same level. The drift term in EQX is verbatim the classical score term in matrix coordinates, exact always. The repackaging into a Hamiltonian, what the abstract advertises, is an analogy in general. A's own phrase for it is a direct quantum analog. Analog is doing a lot of work in that sentence. Apply it. A keeps the noise. How much score does A's drift carry? All of it full score and the noise stays on. You will want that in about 10 minutes. Where does the run finish? On a ring where every state has one height, the target is a delta, and the score is the slope of the log of that. So the thing A's controller needs is infinite exactly when the run lands. A's only word justified for any t above 0. Turn the dial 5, the ring is a smear, the needle flat 10, tighter needle climbs, saturates, 20, 40, the ring goes razor, the needle shoots past 15 and red lines. Now the inset, same runs, and the distance to target bottoms out by 20. The tame setting has the worst reconstruction. The law converges while the control diverges. That inset hits 0.05. What has it measured? The cloud at the end, not the paths. W1 never looked.
Okay, I have to ask, is this just a bad paper? Like, we've been picking at it for 5 minutes now. The caption, the missing numbers, nothing's learned. Is the whole thing shaky, or am I being unfair to them?
Look at that line, 3 places on this page name it. The caption says, norm of the average reverse Hamiltonian. The body says, mean Frobenius norm. The y-axis says, average score. The first two are different quantities. The norm of an average is at most the average of a norm. So which is the plot? A's own symmetry settles it. Spin the ring about n hat at fixed z. The average psi commutes with n sigma. Drop it into the bracket and it collapses. The norm of the average h tilde is identically 0 flat. Look at the plot. One more, nothing is learned anywhere in this paper. The simulations use a truncated Legendre expansion of the exact score. Written down, never fitted. The regression is defined, never run. The abstract says they show how the dynamics can be learnt. Listen to that phrase again, showing how is handing over a recipe. Nobody has cooked it. So the ledger, 1 qubit, a ring, score, truncated learning. None, the dial and the runtime are legible off the figures. Nobody had opened them. A lesson about reading papers. Then the empty boxes, time step, integrator, trajectories, estimator, code on scaling. Could make the approach scalable. Future tense, someone else's method. Approved it, ran 1 qubit. What would it take to build one? Now we go and get the other paper off the shelf. B came out 10 months earlier. It is broader by a mile, and it does the thing A only proposes. It learns something, it runs it, it bounds it. One of them wrote a proof, the other built a machine, and this is B's own map. Where gamma comes from, because B is the only one who says a real apparatus. Couple your qubit to an ancilla at strength lambda for a time delta t. Read it. Lambda up, delta t down. Together, gamma is lambda squared delta t. And what comes back is a tape. What the detector wrote is what you expected plus what you did not. Subtract the expectation, the leftover is the Wiener increment. B reads it exactly that way. The noise is the part that surprised you. Now the Krauss chain, because this part is sound, we checked by hand. Expand the square in the exponent. One term has no state. It goes into the normalization. The observable squares to identity. Out comes B's discrete operator. Exactly. Does it normalize? Sum the two outcomes, identity, plus a correction of order delta t squared. B's supplement asks for equality exactly and does not get it. Drag delta t down and it vanishes. It normalizes to the order the equation earns. B's mixed state equation, two terms. The drift is a double commutator. It drags the state toward the measured axis. Decoherence, nothing random in it. The kick is an anti-commutator against dw, the random walk of collapse. Now watch each alone.
Wait, hold on. Isn't that just A's kick with a root gamma stuck on it? Like, that anti-commutator thing. We literally derived that shape 20 minutes ago on the other paper. Are those the same object, or am I pattern matching?
You are not pattern matching, neither paper writes this down, so it is ours. A's kick for Hermitian jump operators is the anti-commutator of L minus its expectation. B's is root gamma times that shape, identical. One caveat, real A's general operators need not be Hermitian.
So just average the trajectories, right? You've got a load of paths. You average them, and you get the ensemble. That is literally what averaging is for. Why is that a whole appendix then? Like, what am I actually missing here?
Because the expectation inside makes it nonlinear in rho. The naive average is not available. B's fix run an unnormalized state, whose trace carries the probability. Then every path sums at equal weight. Out drops a Fokker, Planck for P of z, in B's own appendix. The Pauli weight, each channel depolarises at 4 gamma over 3, but you measure 1 qubit per s-tep. So each qubit is clock ticks only on its turn. Equalize the clock's 4 gamma over 3n. That n is just the q. Nothing new is happening to the physics. This is what the arena was for. Right rho in the Pauli basis, and the quantum equation becomes a classical Langevin equation for a point in 3 dimensions. The same object you watched for 20 minutes, other coordinates, matching the first mode fixes d at 2 gamma over 3n. Score matching lifted. Take the classical loss you have owned since the pasture. Swap each piece for its Hilbert space cousin. The norm becomes an overlap. Expand to first order in dt, and it collapses onto 1 minus mean overlap squared. This is the only place in either paper you can see what h theta is. 3 real numbers, wiggling 1 per Pascal, Uli. What you will not find in 1900 lines is an architecture, an optimizer, a learning rate, or code. Now B's central move in B's words. If we make the following identification, that is a change of variables, and the residual is forced into a commutator, a bracket spanning exactly the tangent directions at rho. That last part is ours. And the loop closes. The learned reverse unitary expanded is half the score minus the drift. The probability flow OD, the deterministic twin you met in the pasture, now standing in a qubit, and B tabulates 2 branches. B takes 1. B has a convergence theorem, A has none. Look at it before tuning. 2 terms, one grows with the runtime, one shrinks. That tension is real, and the tuned version hides it. Fix the runtime, you get the bound. It rests on 3 hypotheses, and they all have to hold at once. The conditional parts in B's arithmetic. The diffusion term is a full distribution quantity argued from a first moment decay with the word evident. The main text asks an exponent above 1. The proof gives C, so the term does not vanish. The pet's arm, 10 qubits, a transverse field icing chain, 3 qubit patches, fidelities 911963989 at field 1.52 and 5. Read the trend carefully. The best number is the case closest to a trivial product state. B's sharpest idea now, and it is B's, not ours. A thermostat reads its own thermometer. Classically, the state is the observable. Swap in a qubit and the loop breaks. Trajectories are not reproducible. So B builds a classical decoder. So what would you build? Symbol table first, because the next 30 equations will not survive without it. Script D, the dissipator, the averaging blur. Upright D, the diffusion tensor, the kick squared. And a third D floats about, the heat equation scalar. We are not using that one. Struck it. B's sigma is A's upright D. Now the number 1 qubit. Both papers, A's example reduces to isotropic Brownian motion with D equals 2. You watch that on the Legendre ladder. B's randomized Pauli case is spherical diffusion. D equals 2 gamma over 3n. You watched that 10 minutes ago. At gamma 3 and 1 qubit, they read the same. Not loosely. A's drift is minus 4r. B's is minus 4 gamma over 3z, which at 3 is minus 4r. A's tensor expands to 4, identity minus r transpose. B's average tensor is that bracket. Dissipators too. The generators coincide. 3 is not luck. B draws 1 Pauli of 3, a runs 3. Now the guard before you take that anywhere. A has 3 fixed jump operators. B draws the observable at random every step. An outer layer of chances formalism has no slot for. The cloud belongs to the unraveling, not the master equation. They coincide here. 1 qubit, nowhere else. The reverse coefficients agree too. Twice A's D is 4 B's at gamma 3 and N1 is also 4 drift tensor dissipator coefficient. Every one matches, and the meters still read 2 and 1. Somebody has to be wrong. So subtract ours. Neither paper does this at all. A's reverse drift minus the generator plus div D plus D times the score. And a noise tail, that one term B's minus the generator plus half of div D plus D times the score. Where A's noise tail was, B has nothing. Watch the streamlines stop, subtract, the generators annihilate. What survives is half the score, the ITT split, which you met in the pasture. Half of what? The score. A's reverse carries the full score and keeps the noise. B's carries half and no noise. That is the gap. Which is not an error on anybody's part. It is a choice of target. A's trajectories leave traces. B's streamlines leave none. And the histogram reads identical every time. A reverses the process. B reverses the marginal. That table is B's. B tabulated both. Neither noticed the other had taken one. Back to question 1, gathering the same flock 2 ways. Who pushes harder? Dog 1 twice as hard, and both dogs are right. Dog 1 fought the wandering and the clock. Dog 2 only ever had the clock. They were never doing the same job. One place I do want to push, B writes, therefore generated by a unitary evolution, it does not follow. And here is A's counterexample, running, purity, preserving, reverse, stochastic, never leaving the surface. B's own correct sentence is a page away. Delete the bad line, B's construction. Derivation and theorem stand.
Wait, isn't this just the Petz map? Like, that is the quantum time reversal, the one that everybody knows. And you told us that a set it wasn't. So which is it?
Both. Watch B split. B has 2 arms, the headline unitary and Petz. B's Pet's drift is 4 gamma over 3n times the perpendicular gradient of log PA's, is sigma times the score, and sigma is twice d, the same expression. What coincides with A is B's Pet's arm. A denies the link, B proves it, both right, because B's proof lives in a limit B calls unphysical. And the last one, approves the score can only push along the kicks, all tangent. B forces its residual into a commutator spanning those same directions, same structure, opposite sides. Neither paper says it. That reading is ours. And the one I keep returning to, A's lemma licenses B's parametrization. B assumes it, never checks. That is a gap in the write-up, and it happens to have already filled it. On citations, a limit. B never cites A, grep it, 0 hits, and B could not have. B is 10 months earlier. A cites 6 papers in a cluster, one matching B's authors and year. Neither bibliography is on disk. Both papers write the same 1982 equation, and neither names it for the quantum case. They arrived at the same marginal flow from opposite ends by 2 branches of a duality. One tabulated and neither noticed the other took. Approves one result about 1 qubit. B learns, bounds. Put them side by side and you still do not have a working machine. Back to the field, same fence, same crooks against the rail, the flock back on its crease. The next few minutes are a test, not a summary, I ask. You answer, then I answer. 2 dogs, same crease, the same morning. One of them leans hard, one leans light. How much harder? Twice, because dog one's flock never stopped nosing, and that nosing spreads them out again every second he works. He fights the spread and the clock. Dog 2 only had the clock. One sheep's whole day drawn as a trail, the flock's shape stamped over the top, which is which. The stamp is the snapshot. The trail is the path. 2 completely different routes can leave the same stamp. Watch. The shape cannot tell them apart, which is why getting the stamp right is the easy half of the job, and getting the paths right is the hard one. The sheep noses left. The post gets a notch. Noses right. Another. Where did that wandering come from? Nobody sprinkled it on. No extra hand. The nosing and the notch are one event seen twice. The wandering is the record, and the record is the wandering. That is the thing both papers upgraded on the classical picture. That fan is every direction this one sheep actually nosed in. Where is the dog allowed to push? Only along the fan. Push anywhere else, and the arrow has nowhere to live. It grays, stalls, snaps back. That is the reason the reversal is a rotation. You will not find that sentence in either paper. We put it together ourselves.
Okay, but come on, 2 groups. Same equation, same score thing. It is one object with different letters, right? Just say it. They found the same thing.
2 dogs, same morning, same finish. One was fighting the wandering as well. So he leaned twice as hard. 2 real jobs, 1 factor of 2. One side proved it. The other built it. Neither is finished without the other. 3 words for the way back minus div score. Flip the lean, mind the changing wander. Follow the uphill home. That is the whole of A's reverse drift. Nobody built this. A's reverse keeps the noise so it could watch the state while it works. B has the decoder that reads it. What would you get if you joined them?